Hello, in this lecture I will answer two questions. In the first question we find out the radius of this circle, and in the second question we find out the area of this green shape using two different methods. So we start with the first question. In the drawing we have quadrilateral ABCD that is described by this circle. AB equals to AD equals to 4, BC equals to 6, DC equals to 8. Here I have a test. It's to find out the radius of this circle. So first of all, we define this angle BCD is theta. Therefore, the opposite angle, this is the opposite angle of theta, must be equal to 180 degrees minus theta. Why? Because of the fact that 180 degrees minus theta plus theta equals to 180 degrees. That is the sum of those two opposite angles inside quadrilateral ABCD. That is the cyclic quadrilateral. This is actually according to Rule 70. So if we click on Rule 70, according to Rule 70, in cyclic quadrilateral, the sum of the opposite angles is equal to 180 degrees. That is to say, here the sum of those two opposite angles is equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. Likewise, the sum of those two opposite angles is also equal to 180 degrees. That is to say, gamma plus delta also equals to 180 degrees. So, we can integrate Rule 70, number 1. The sum of those two opposite angles must be equal to 180 degrees. Theta plus this missing angle total must be equal to 180 degrees. Therefore, this missing angle must be equal to 180 degrees minus theta, or because of the fact that 180 degrees minus theta plus theta is equal to 180 degrees. That is the sum of those two opposite angles inside cyclic quadrilateral ABCD. So, in the next step, we join points B and D together by step 9. By joining points B and D, we divided quadrilateral ABCD into two parts. The first part is this triangle ABD, and the second part this is triangle BDC. So we will implement the law of cosines on both triangles. So first of all, we implement the law of cosines in this green triangle ABD, and then we implement the law of cosines in this red triangle BDC. In this white triangle BDC. So if we click on the law of cosines, the law of cosines is true in any triangle. This is triangle ABC, that could be any triangle. AB equals to units in its left, side AC equals to units in its left, side BC equals to 3 units in its left. This is angle BAC, that is equals to theta degrees inside. So in this triangle ABC, that could be any triangle according to the law of cosines. The following equation is 2. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. We can actually implement the law of cosines on this great triangle ABD. According to the law of cosines on this great triangle ABD, the following equation is 2. BD square equals to AB square plus AD square minus 2 times AB times AD times cosine 180 degrees minus theta. Repeat again, according to the law of cosines, this rectangle ABD, the following equation is false. DB square equals to AB square plus AD square minus 2 times AB times AD times cosine 180 degrees minus theta. This equation is the implementation of the law of cosines in this green triangle ABD. We have the trigonometric identity that says that cosine 180 degrees minus theta equals to minus cosine theta. So, we settle cosine 180 degrees minus theta in this equation 1 by minus cosine theta. We get that according to equation 1, BD square equals to AB square. AB is 4, therefore AB square is 4 squared, that is 16. Plus AD square. AD is also 4, so AD square is 4 squared, that is also 16. Minus 2 times AB is 4, times AD is also 4, times cosine 180 degrees minus theta, that is actually minus cosine theta. Again, cosine 180 degrees minus theta is equal to minus cosine theta. So here we have minus times minus is plus. So this expression in total it is a positive expression. We get in total that according to equation 1, BD square equals to 16 plus 16 is 32. This is a positive expression, so it is plus 2 times 4 is 8, 8 times 4 is 32. So total this expression equals to 32 times cosine theta. So according to equation 1, if we found out that BD square equals to 32 plus 32 times cosine theta. Likewise, we represent the law of cosines on this right triangle BDC. On this right triangle BDC, according to the law of cosines, BD square equals to BC square plus DC square minus 2 times BC times DC times cosine theta. And again, in this right triangle BDC, according to the law of cosines, the following equation is true. This is equation 2. BD square equals to BC square plus DC square minus 2 times BC times DC times cosine theta. BD is the missing side, so write as it is. So that's BD square equals to BC square. BC is 6, therefore BC square is 6 squared, that is 36. Plus DC square. DC is 8, therefore DC square is 8 squared, that is 64. Minus 2 times BC, that is 6, times DC, that is 8. Times cosine theta. So now according to equation 2, if you found that BD square equals to 36 plus 64 minus 2 times 6 times 8 times cosine theta. So BD square equals to 36 plus 64 is 100 minus 2 times 6 is minus 12, minus 12 times 8 is minus 96 times cosine theta. So total according to equation 2, if you found out that BD square equals to 100 minus 96 times cosine theta. This is according to equation 2, while according to equation 1, we already found out that BD square equals to 32 plus 32 times cosine theta. So we have two different equations for BD square. Equation 1 and equation 2. Therefore, we get equation 3. And again, we get equation 3. That states that BD square, according to equation 1, must be equal to BD square according to equation 2. Very simple equation. BD square according to equation 1 equals to 32 plus 32 times cosine theta. And it must be equal to BD square according to equation 2. BD square according to equation 2 equals to 100 minus 96 times cosine theta. So total according to equation 3, we have found out that 32 plus 32 times cosine theta equals to 100 minus 96 times cosine theta. Here we'll subtract 32 from this equation, equation 3. So here 32 will get cancelled, we left only this side of the equation 3 with 32 times cosine theta, while on the other side of this equation 3 we have 100 minus 32 is 68 minus 96 times cosine theta. So here we relate to this equation, equation 3, 96 times cosine theta plus 96 cosine theta. So 96 cosine theta minus 26 cosine theta is 0, so this expression will get cancelled. So in this side of the equation 3, we left only with 68, while on the other side of the equation 3, we have 96 cosine theta plus 32 cosine theta. Total is equal to 128 cosine theta. So total according to equation 3, we should find out that 128 cosine theta equals to 68. Here we divide this equation 3 by 128. And get that according to this equation 3, we should find out that in total cosine theta equals to 68 over 128. Here we divide both the numerator and the denominator of this number by 2. 68 over 2 is 34, and 128 over 2 is 64. Likewise, we divide this expression also on the denominator of this denominator of this number by 2, and we get that 34 over 2 is 17. 64 over 2 is 32. Those two sides of the equation are equal, those two sides of this equation 3 are equal to each other. That is to say, cosine theta equals to 17 over 32. In total, if we found out that according to equation 3, cosine theta equals to 17 over 32. We have the trigonometric identity that says that sinus square theta plus cosine square theta equals to 1. So here we subtract from this trigonometric identity cosine square theta. And we get that sinus square theta equals to 1 minus cosine square theta. Here we take out all of this equation and finally get that sinus theta equals to the square root of 1 minus cosine square theta. We have already found out that cosine theta equals to 17 over 32. Cosine theta equals to 17 over 32. Here we will square this equation. And we'll get that cosine square theta equals to 17 over 32 squared. 17 over 32 squared equals to 0.2822. So if we found out that cosine square theta equals to 0.2822. Therefore, we can solve cosine square theta this trigonometric identity by 0.2822. We do it now, we get that sinus theta equals to the square root of 1 minus cosine square theta. Cosine square theta equals to 0.2822. En total, if you found out that sinus theta equals to the square root of 1 minus 0.822. 1 minus 0.822 equals to 0.717. So inside the root we left only with 0.7177. So sinus theta equals to the square root of 0.7177. The square root of 0.7177 is equal to 0.847. So in total, if you found out that sinus theta equals to 0.847. Then again, found out that sinus theta equals to 0.847. What is the value of BD itself? Actually, according to equation 1, we already found out that BD square equals to 32 plus 32 times cosine theta. So BD square, according to equation 1, BD square equals to 32 plus 32 times cosine theta. And cosine theta equals to 17 over 32. So it's going to be cosine theta by 17 over 32. So it is 17 over 32. We have 32 in the numerator, 32 in the numerator, so 32 will get cancelled. We left only with 17 here. So if you found out that according to equation 1, BD square equals to 17 and 32 plus 17. 32 plus 17 is 49. Here we take out of this equation and find that BD equals to the square root of 49, that is 7. So in total, we found out that BD equals to 7 units in itself. This is called BD, that equals to 7 units in itself. So BD equals to 7. And we already found out that sinus theta equals to 0.847. In the next step, we will implement the law of sines on this right triangle BDC. So I quickly click on the law of sines. The law of sines is true in any triangle. So this is triangle ABC that could be any triangle. Triangle ABC is inscribed by this circle. The radius of this circle is R, capital R. AB equals to 2 units in itself, AC equals to B units in itself, BC equals to A units in itself. This is angle BC, that equals to capital A degrees inside. Likewise, this is angle ACB, that equals to capital C degrees inside. And finally, this is angle ABC, that is equals to capital B degrees inside. So in this triangle ABC, that could be any triangle according to the law of sines in its full version. The following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And now the radius of this circle that blocks triangle ABC. Again, according to the law of science, according to the law of science, this triangle ABC that could be any triangle, the following equation is 2. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And now the radius of this circle that blocks triangle ABC. So we can actually implement the law of science in our drawing. Implement the law of science. This one triangle BDC. First of all, triangle BDC is inscribed by this circle. Why triangle BDC is inscribed by this circle? Because of the fact that all the three vertices of the right triangle BDC, that is to say B, D, and C, lies on the circle itself. So triangle BDC is inscribed by this circle, and therefore we can implement the law of science in its full version. According to the law of science in its full version, in the right triangle BDC, the following equation is true. BD over sinus theta equals to 2R. And again, according to the law of science in its full version, in this right triangle BDC, the following equation is true. BD over sinus theta equals to 2R. This is actually the implementation of the law of science in its full version on our right triangle BDC. BD is 7. Over sinus theta. Sinus theta is 0.847. So 7 over 0.847 equals to 2R. And R is the radius of this circle that blocks triangle ABC. R is also the radius that we are looking for in this question. 7 over 0.847 is equal to 8.2644 equals to 2R. Or 2R equals to 8.2644. Here we divide this equation by 2 and finally get that R, that is the radius of this circle, that is the radius that we are looking for in this question. R equals to 8.2644 over 2, this is 4.132 units in itself. And again, in total, if you found out that the radius R, this is the radius of this circle that we are looking for in this question, is equal to 4.132 units in itself. So we finished the answer of the first question. In the next step, I present you the second question, and we solve the second question by using two different methods. In the second question, our task is to find out the area of this venture. So in the drawing, we have the big triangle ABC, the big right triangle ABC. This is angle ABC, that is right angle. This is angle ACB, that equals to theta. AP equals to 5 units in its left, BB equals to 4 units in its left. Again, our task is to find out the area of this range shape. So, first of all, we will complete the missing angle in this drawing according to the rule that says that the sum of the angles in any triangle is equal to 180 degrees. So in the big right angle ABC, this angle equals to 90 degrees, this angle equals to 2 theta, therefore this missing angle must be equal to 90 degrees minus 2 theta. Likewise, this right lower triangle PBC, this angle equals to 90 degrees, this angle equals to theta, therefore this missing angle must be equal to 90 degrees minus theta. According to the symbol that says that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we will do a construction. That is to say, from this point to point B, we will do perpendicular on AC. Again, from point B, we will do perpendicular on AC. So actually, this angle equals to 90 degrees in its size, and this angle also equals to 90 degrees in its size according to our construction. We define the touching point of the perpendicular from point B in AC. This point is point Q. By doing this construction, we can do the green right triangle PQC. In the green right triangle PQC, this angle equals to 90 degrees, this angle equals to theta. Therefore, this missing angle must be equal to 90 degrees minus theta according to the symbol that says that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we prove that the upper right triangle PQC can go into this right lower right triangle PBC according to angle side angle rule. So we have to prove that the upper green triangle PQC can go to the right lower triangle PBC according to angle side angle rule. So why those two right angles can go into each other? First of all, those two angles are both equal to 90 degrees minus theta, and therefore they are equal to each other. So actually this is angle QPC. And again, right triangle PQC is equal to this angle. This is actually angle CPB. In the right triangle BPC. Repeat again. I should found out that angle QPC in the right triangle PQC equals to angle CPB in the right triangle PBC. They are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, this is side PC, this is the common side that belongs to both triangles. We can write down that PC equals to itself is a common side that belongs to both triangles. And finally, those two angles are both equal to theta, and therefore they are equal to each other. So here this is angle QCP. The green triangle PQC and it is equal to this angle, the angle PCB in the right angle PBC. And again, if we found out that angle QCP in the green triangle PQC equals to angle PCB in the right angle PBC, they are both equal to theta, and therefore they are equal to each other. So in total, if you found out that those two right angles can point to each other according to angle side angle rule. The green triangle, the green right triangle PQC conjoint, this is the sum of conjoint to the white triangle, the white right triangle PBC according to angle side angle rule. What is angle side angle rule? If we found out that those two angles and the side that is included between those two angles, the first side PC, in the green triangle QPC are corresponding equal to those two angles, and the side that is included between those two angles is also side PC in this right triangle PBC. Therefore, those two right angles can point to each other according to angle side angle rule. We have those two angles and the side that is included between those two angles in the green triangle are corresponding equal to those two angles and the side that is included between those two angles in the white triangle. Therefore, those two right angles can point to each other according to angle side angle rule. And for the fact that those two right angles can point to each other, we will derive that the corresponding sides must be also equal to each other in the lengths. That is to say, PQ equals to PB. PQ equals to PB. Why PQ in the green triangle is the corresponding side of PB in the white triangle? Because of the fact that PQ is located in front of angle theta, likewise PB in the white triangle also located in front of angle theta. Therefore, they are equal to each other in the length. According to the rule, that corresponding sides in congruent triangles are equal to each other. Those two triangles can point to each other, therefore the corresponding sides must be also equal to each other in the length. That is to say, PQ equals to PB. But PB equals to 4. So we can write that PB equals to 4. And from this equation, PQ equals to PB equals to 4. We derive that PQ must be also equal to 4 units in its length. This is the missing side PQ. It also equals to 4 units in its length. From the drawing, it is very easy to say that the big right triangle ABC is similar to this green triangle APQ. The big triangle ABC is similar, this is the sign of similar, to this green small right triangle APQ. According to angle similarity rule. That is to say, this is angle A, this is the common angle that belongs to both triangles. So you might know that angle A equals to itself is the common angle that belongs to both triangles. Likewise, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to theta and therefore they are equal to each other. Why this angle equals to theta? This angle equals to theta according to rule 3 that says that the sum of the angles from one side of the side line is equal to 180 degrees. If we define the size of this missing angle PQ as y, then AEB is one side of triangle ABC, therefore it is absolutely straight line. So if we focus on the left side of the straight line AB at point B, if the sum of the areas must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the areas from one side of the straight line is equal to 180 degrees. So which areas we have the left side of the straight line AB at point B. Here SL is a version for straight line. This is the missing angle Y, plus this angle equals to 90 degrees minus theta inside, plus this angle is also equals to 90 degrees minus theta inside. Total the sum of those angles must be equal to 180 degrees according to rule 3. And again, total we found out that y plus 90 degrees minus theta plus 90 degrees minus theta equals to 180 degrees according to rule 3. So in this end of the equation we have y plus 90 degrees plus 90 degrees is 180 degrees. Minus theta is minus 2 theta equals to 180 degrees. So here we subtract 180 degrees from this equation. So here 180 degrees will get cancelled, and also 180 degrees will get cancelled. So this side of the equation we left with nothing, that is to say 0. And on the other side of the equation we left only with y minus 2 theta. So then we found out that y minus 2 theta equals to 0. Here we add 2 theta to this equation, and finally get that the missing angle y is equal to 2 theta. That is to say, angle APQ, this is the missing angle, this is also defined as y, equals to 2 theta degrees in size. Repeat again, I should found out that the big right triangle ABC is similar to this small green triangle APQ according to angle similar to. That is to say, this angle 8 is the common angle that belongs to both triangles, so we can write down that angle 8 equals to itself is the common angle that belongs to both triangles. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 2 theta and therefore they are equal to each other. So in total, I should found out that all the triangles of this big right triangle ABC correspond equal to all the triangles of this small green triangle APQ. Therefore, those two right triangles can write to each other according to angle similar to. The big triangle ABC similar to the big triangle ABC similar to the green small triangle APQ according to angle similar to 1. And for the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AP of the green small triangle over side AC of the big right triangle ABC equals to side PQ of the green small triangle over side BC of the big triangle ABC. And again, in total, we have found out that from the fact that the big right triangle ABC is similar to this green small triangle PQ, the following relationship exists between the sides. We derive that side AP of the green small triangle APQ over side AC of the big right triangle ABC equals to side PQ of the green small triangle APQ over side BC of the big right triangle ABC. AB equals to 5 according to what is given as the question over AC. We define the ref of AC as A, and the ref of BC is B. So AC equals to A according to our definition. We substitute AC by A. And it is equals to PQ. PQ equals to 4 over BC. BC equals to B according to our definition also. So substitute BC by B. Substitute BC by B. Then total, if you found out that 5 over A equals to 4 over B. Here we'll cross multiply this equation. And we get that 5b equals to 4a. Again, if you found out the total, that 5b equals to 4a. That is to say, if we define a, if a equals to 5x, what is the value of b? If a equals to 5x, then we have to substitute this equation by 5x. We do it now, we get it 5b equals to 4 times a, and a is 5x. So we have 5 on both sides of this equation, so 5 will get cancelled. So inside of the equation we have to leave b equals to 4x. In total we found out that if a equals to 5x, then b must be equal to 4x. And if a equals to 5x, then b must be equal to 4x. Again, if we found out that if a equals to 5x, then b must be equal to 4x. The next step, we will implement the Pythagoras theorem on this big right triangle ABC. And again, we will implement the Pythagoras theorem on this big right triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. So in the big right triangle ABC, here by PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in this big right triangle ABC, the following equation is to AC squared, that is the square of the hypotenuse, must be equal to AB squared plus BC squared. And again, according to Pythagoras theorem, in this big right triangle ABC, the following equation is to AC squared, that is the square of the hypotenuse, equals to AB squared plus BC squared. AC equals to A and A equals to 5x. Again, AC equals to A and A equals to 5x. Therefore, AC equals to 5x. If AC equals to 5x, it means that AC squared equals to 5x squared. 5x squared is 25x squared. So total is equal to 25x squared. And it equals to AB squared. AB in total equals to 5 plus 4, that is 9, therefore AB squared equals to 9 squared, that is 81. So AB squared equals to 81. Plus BC squared. According to our definition, BC equals to B and B equals to 4x. Therefore BC in total equals to 4x. Therefore BC squared equals to 4x squared. 4x squared is 16x squared. So total found that BC squared equals to 16x squared. So total found out that 25x squared equals to 81 plus 16x squared. So here we subtract 16x squared from this equation. 16x squared minus 16x squared is also this equation, this expression will be cancelled. In this side of the equation, but on the other side of the equation we have 25x squared minus 16x squared is 9x squared equals to 81. Here we divide this equation by 9 and if I get that 9x squared over 9 is x squared, and 9x squared over 9 is x squared, and this equals to 81 over 9. 81 over 9 is 9. So in total, we should know that x squared equals to 9. Here we take out all of the equation, if I get that x equals to the square root of 9, that is 3. So in total, we should know that x equals to 3, it's in its name. Is equals to a and a equals to 5x. 5x is 5 times 3, that is 15. So in total is equals to 15 is in its name. Likewise, b is equals to b and b equals to 4x. 4x is 4 times 3, that is 12. So in total b is equals to 12 units in its name. Our task is to find out the area of this green shape. So what is the area of this green shape? From the drawing, it is very easy to see that the green shape is actually the green triangle APC. So our task is to find out the area of this green triangle APC. Actually, note that the area of any triangle equals to the base of the triangle times the height to the base over 2. So the area of this green triangle APC equals to the base of the triangle APC. So we choose the base of this triangle APC as AC. The height to the base must create 90 degrees with the base. PQ must definitely create 90 degrees with AC. Therefore, the height to the base is PQ over 2. So in total, we found out that the area of this green shape equals to the area of this green triangle APC, and the area of the green triangle APC equals to AC is 15 times PQ is 4 over 2. So in total, we found out that the area of the green shape equals to 15 times 4 is 60, 60 over 2 is 30. The area of the green shape according to the first method is equal to 30 square units in size. And again, in total, we found out that the area of this green shape, this is the area that we're looking for in this question, according to the first method, is equal to 30 square units in size. So we finished with the first method. In the next step, I present you how to find out the area of this green shape by using the second method, in a different way, the second method. We focus on this white lower triangle PBC. This white lower triangle PBC, it is very easy to see that tangent theta equals to PB over BC. Again, tangent theta equals to PB over BC. So it is known. The white lower triangle PBC, it is very easy to see that tangent theta equals to PB over BC. Repeat again. In the white lower triangle PBC, tangent theta equals to PB over BC. We define BC as B. And so we found out that Let's only to equation 1 times theta equals to PB. PB is 4 over BC. BC equals to B units in itself according to our definition. So in total, we have found out that according to equation 1 times theta equals to 4 over B. The next step, we'll focus on this big right triangle ABC. This big right triangle ABC, it is very easy to see that times 2 theta equals to AB over BC. Again, times 2 theta equals to AB over BC. And again, the big right triangle ABC, it's very easy to see that minus 2 theta equals to AB over BC. What is the value of AB? AB in total equals to 5 plus 4, that is 9. Over BC, BC equals to B. So in total, we found out that according to equation 2, times 2 theta equals to 9 over B. This is according to equation 2. Right, according to equation 1, we already found out that times theta equals to 4 over B. We have the trigonometric identity that says that tangents to theta equals to 2 times tangents theta over 1 minus tangents square theta. We already found out that tangents to theta equals to 9 over B. So we substitute tangents to theta in this trigonometric identity by 9 over B. And it equals to 2 times tangent theta. So it is 2 times tangent theta, and tangent theta is 4 over B. So it is 2 times 4 over B over 1 minus tangent square theta. Tangent theta equals to 4 over B, therefore tangent square theta must be equal to 4 over B squared. 4 over B squared equals to 16 over B squared. So tangent square theta equals to 16 over B squared. So in total, if you found out that 9 over B equals to 2 times 4, that is 8 over B over 1 minus 16 over B squared. Then again, in total, if you found out that according to equation 3, 9 over B equals to 8 over B over 1 minus 16 over B squared. So I write it now. In total, according to equation 3, we have found out that 9 over B equals to 8 over B over 1 minus 16 over B squared. Then again, in total, if you found out according to equation 3, 9 over B equals to 8 over B over 1 minus 16 over B squared. So here we multiply this equation by 1 minus 16 over B squared. Again, multiply this equation 3 by 1 minus 16 over b squared. So here, this is 1 minus 16 over b squared over 1 minus 16 over b squared. So 1 minus 16 over b squared will cancel. While on the other side of this equation 3, we have 9 over b times 1 minus 16 over b squared equals to 8 over b, because 1 over 16 over b squared, 1 over 16 over b squared, we get cancelled, we have to only this out of the equation by only with 8 over b. So total, according to equation 3, we have found out that 9 over b times 1 over 16 over b squared equals to 8 over b. We have b on both sides of this equation, so b will get cancelled. Also cancel b, this side of equation 3 we left only with 9 times 1 over 16 over b squared, and on the other side of this equation 3 we left only with 8. So here we'll open the brackets on this side of this equation, equation 3. If I get that according to equation 3, we have 9 times 1 is 9, and 9 times 1 is 16 is minus 144. So in total, this expression equals to minus 144 over b squared equals to 8. Here we subtract 8 from this equation, equation 3. So we get it according to equation 3. Nine minus 8 is 1. So here we have in total 1 minus 144 over b squared, while on the other side of the equation 8 minus 8 is 0. So here we have to this equation, equation 3, 144 over b squared. So in this the equation we have 1 and 144 over b squared minus 144 over b squared equals to 0. And on the other side of this equation we have 0 plus 144 over b squared equals to 144 over b squared. So in total we found out that 1 equals to 144 over b squared. Here we'll multiply this equation by b squared, and finally get that b squared equals to 144. B squared equals to 144. Here we take root out of this equation, and we get that b equals to the square root of 144. The square root of 144 is 12. So in total we found out that b equals to 12 for instance now. BC equals to B equals to 12 for instance. So in total BC equals to 12. Our task is to find out the area of this green shape. So what is the area of this green shape? The green shape is essentially the green triangle APC. So our task is to find out the area of this green triangle APC. Again, our task is to find out the area of the green triangle APC. The area of green triangle equals to the base of the triangle times the height of the base over 2. We'll choose the base of this green triangle APC as AP. AP is the base times the height of the base. It is the height to the base or the height to the extended base. The extended base AP is AB. Again, the extended base AP is AB. So the height to the base must get 90 degrees with AB. CB definitely gets 90 degrees with AB, therefore CB is the height to the base AB. So the height is CB over 2. So total, if you found out that the obligation equals to the base of the rectangle ABC, that is actually AP, according to our choice, times the height to the base is CB over 2. AP equals to 5, CB equals to 12 over 2. So in total, if you found out that according to the second method, the obligation equals to 5 times 12, that is 60 over 2. 60 over 2 is 30. So according to the second method, you have the green shape is also equals to 30 squares in size. So again, if you found out that in both methods, the area of this green shape is equal to 30 squares in size. So we finish with the second question. In the next step, so the lecture, we start with the repetition of the first question and then repeat on the solution of this second question on both methods. In the first question, our task is to find out the radius of this circle. So in the drawing, we have quadrilateral ABCD that is described by this circle. AB equals to AD equals to 4, BC equals to 6, DC equals to 8. Again, our task is to find out the radius of this circle. So first of all, we define this angle BCD as theta. So in quadrilateral ABCD that is described by this circle, the opposite angle must be equal to 180 degrees minus theta. According to the rule that in any cycle quadrilateral, the sum of those two opposite angles must be equal to 180 degrees. If this angle equals to 180 degrees minus theta, we get that 180 degrees minus theta plus theta equals to 180 degrees. That is the sum of those two opposite angles. According to rule 70. So if we go rule 70, according to rule 70, in any cycle quadrilateral, the sum of the opposite angles is equal to 180 degrees. Quadrilateral ABCD is definitely a cycle quadrilateral because it is described by this circle. Therefore, the sum of those two opposite angles must be equal to 180 degrees. That is to say, alpha plus beta equals to 180 degrees. Likewise, the sum of those two opposite angles must be also equal to 180 degrees. That is to say, gamma plus theta equals to 180 degrees. So we can implement rule 70 in our drawing. One point in our drawing, on the other ABCD is a cyclic quadrilateral. Therefore, the sum of those two opposite angles must be equal to 180 degrees. This angle equals to theta according to our definition. Therefore, this angle must be equal to 180 degrees minus theta. Why? Because of the fact that 180 degrees minus theta plus theta equals to 180 degrees. That is the sum of those two angles inside quadrilateral ABCD. That is a cyclic quadrilateral. Therefore, this angle must be equal to 180 degrees minus theta. In the next step, we join points B and D together by straight line, and we implemented the law of forces of both those two triangles. So first of all, we implemented the law of forces on this green upper triangle ABD. So we click on the law of forces. First of all, the law of cosines is true in any triangle. So this is triangle ABC that could be any triangle. AB equals to anything itself, AC equals to B anything itself, BC equals to C anything itself. This is going to be AC is equals to theta degrees in size. So in this triangle ABC that could be any triangle, according to the law of cosines, the following equation is 2. C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. So we can implement the law of cosines in this rectangle, triangle ABD. This rectangle, triangle ABD, according to the law of cosines, the following equation is 2. BD squared equals to AB squared plus AD squared minus 2 times AB times AD times cosine 180 degrees minus theta. Okay, again, this rectangle ABD, according to the law of cosines, the following equation is 2. BD squared equals to AB squared plus AD squared minus 2 times AB times AD times cosine 180 degrees minus theta. We have the trigonometric identity that says that cosine 180 degrees minus theta equals to minus cosine theta. Therefore, we can substitute cosine 180 degrees minus theta in this equation 1 by minus cosine theta. So in total, we should find out that BD squared equals to AB squared. AB is 4, therefore AB squared is 4 squared, this is 16. Plus AD squared. AD is also 4, therefore AD squared is 4 squared, this is 16. So we have dV squared equals to 16 plus 16 minus 2 times 4 times cosine 180 degrees minus theta. So it is minus 2 times 4 times 100 times cosine 180 degrees minus theta. Cosine 180 degrees minus theta equals to minus cosine theta. So this cosine 180 degrees minus theta in this equation 1 by minus cosine theta. So in total here we have minus times minus is plus. So this is a positive expression. So in total we should find out that dB squared equals to 16 plus 16 is 32. And this is a positive expression, so it is plus 2 times 4 is 8, 8 times 4 is 32 times cosine theta. So in total this expression equals to plus 42 times cosine theta. So in total according to equation 1 we should find out that dB squared equals to 32 plus 32 times cosine theta. Likewise, implemented the law of cosines in this white triangle, triangle BDC. This white triangle BDC, according to the law of cosines, the following equation is 2. BD squared equals to BC squared plus DC squared minus 2 times BC times DC times cosine theta. And again, this white triangle BDC, according to the law of cosines, the following equation is 2. BD squared equals to BC squared plus DC squared minus 2 times BC times DC times cosine theta. BD is the missing side, so it is BD squared equals to BC squared. BC is 6, therefore BC squared is 6 squared, that is 36, plus DC squared. DC is 8, therefore DC squared is 8 squared, that is 64, minus 2 times 6 times 8 times cosine theta. So total according to equation 2, we should find out that BD squared equals to 36 plus 64 minus 2 times 6 times 8 times cosine theta. So in total, according to equation 2, BD squared equals to 36 plus 64 is 100, minus 2 times 6 is minus 12, minus 12 times 8 is minus 96 times cosine theta. So in total, according to equation 2, we should find out that BD squared equals to 100 minus 96 times cosine theta. This is according to equation 2, while according to equation 1, we already found out that BD squared equals to 32 plus 32 times cosine theta. So we have two different equations for BD squared. Equation 1 and equation 2. Therefore, we get the equation 3 that says that BD squared according to equation 1 must be equal to BD squared according to equation 2. Very simple equation. So BD squared according to equation 1 equals to 32 plus 32 times cosine theta. It must be equal to BD squared according to equation 2. BD squared according to equation 2 equals to 100 minus 96 times cosine theta. 100 minus 96 times cosine theta. So in total, according to equation 3, we actually found out that 32 plus 32 times cosine theta equals to 100 minus 96 times cosine theta. Here subtract 32 from this equation, so here 32 gets cancelled. In this side of the equation, we have to with 32 times cosine theta. When on the other side of this equation 3, we have 100 minus 32 is 68 minus 96 times cosine theta. So in total, according to equation 3, we should find out that 32 times cosine theta equals to 68 minus 96 cosine theta. So here we added 96 cosine theta to this equation. So 96 cosine theta minus 96 cosine theta is 0. So here 96 cosine theta we can cancel. And this side of the equation we have to leave 68. While on the other side of this equation we have 32 cosine theta times 96 cosine theta is equal to 128 cosine theta. So total according to equation 3, we found out that 128 cosine theta equals to 68. Here we divide this equation 3 by 128. So in this side of the equation we have to leave cosine theta equals to 68 over 128. 68, we divided both the numerator and the denominator of this number by 2. 68 over 2 is 34, 128 over 2 is 64. Likewise, we divided both the numerator and the denominator of this number by 2. 34 over 2 is 17, and 64 over 2 is 32. So in total, we found out that cosine theta equals to 17 over 32. Cosine theta equals to 17 over 32. We have the trigonometric identity that said that sine square theta plus cosine square theta equals to 1. Here we subtracted cosine square theta from this trigonometric identity. We found out that sine square theta equals to 1 minus cosine square theta. Here we took out of this equation and we got that sine theta equals to the square root of 1 minus cosine square theta. But we already found out that cosine theta equals to 17 over 32. We squared this equation and found out that cosine square theta must be equal to 17 over 32 squared. 17 over 32 squared equals to 0.2822. So in total we found out that cosine square theta equals to 0.2822. Cosine square theta equals to 0.2822. But according to this trigonometric identity, we only found out that sine theta equals to the square root of 1 minus cosine square theta. Therefore, consider cosine square theta in this trigonometric identity by 0.2822. And consider cosine square theta in this trigonometric identity by 0.2822. We didn't if we found out that sine theta equals to the square root of 1 plus 0.2822. So sine theta equals to 1 minus 0.822 is 0.7177. So we found out that sine theta equals to the square root of 0.7177. The square root of 0.7177 is 0.847. So in total we found out that sine theta equals to 0.847. What is the value of this code BD? According to equation 1, we only found out that dB squared equals to 32 plus 32 times cosine theta. So dB squared equals to 32 plus 32 times cosine theta. Cosine theta is equal to 17 over 32. So substitute cosine theta here by 17 over 32. We have 32 in the numerator, 32 in the denominator, so 32 we can cancel. So this expression we have to only with 17. In total, we found out that dB squared equals to 32 plus 17, that is 49. So dB squared equals to 49. Here we took out of this equation, and we found out that BD equals to the square root of 49 is 7. So BD equals to 7. BD equals to 7 units and 7. So in total, we found out that BD equals to 7 units and 7, and sine theta equals to 0.847. In the next step, we implemented the law of sines on this right triangle BDC. So let's review on the law of sines. This is a triangle ABC that could be any triangle. Triangle ABC is described by this circle. The radius of this circle is R. So the law of sines in its full version is as follows. AB equals to C units in itself, AC equals to B units in itself, BC equals to A units in itself. This circle BAC is equals to capital A degrees in size. This circle ACB is equals to capital C degrees in size. This circle ABC is equals to capital B degrees in size. So in this drawing, according to the law of sines, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And now the radius of this second that blocks triangle ABC. And again, according to the law of sines in this solution, now the following equation is 2. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And now the radius of this second that blocks triangle ABC. So we can definitely implement the law of sines in our drawing. Why? Because first of all, the white triangle BDC is definitely inscribed by this circle. Why? Because of the fact that all the three vertices of the white triangle B, D, and C lie on the circle itself. Therefore, triangle BDC is inscribed by this circle. Therefore, we can implement here the law of sines in its full version. According to the law of sines in its full version, BD over sinus theta equals to 2R. Again, BD over sinus theta equals to 2R, and R is the radius of this circle that blocks triangle ABC. And R is also the radius of this circle that we are looking for in this question. So in total, if you found out that according to the law of sines, if we implement the law of sines in the white triangle BDC, we get that BD over sinus theta equals to 2R. BD is 7, sinus theta is 0.847. So 7 over 0.847 equals to 8.2644 equals to 2R. Here we divided this equation by 2 and found out that the radius R equals to 8.2644 over 2 is 4.132 units in itself. So the radius of this circle, that is the radius that we are looking for this question, is equal to 4.132 units in itself. So we finish to repeat on the first question. In the next step, repeat on the solution of the second question on both methods. In the second question, our task is to find out the area of this grand shape. So in the drawing, we have the big right triangle ABC. This is angle ABC, this is the right angle, this is angle ACB, this is equal to 2 theta degrees in size. PB equals to 4, AP equals to 5. Again, our task is to find out the area of this grand shape. First of all, we found the missing angles in our drawing. According to the rule that said that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on the big right triangle ABC, this angle equals to 90 degrees, this angle equals to 2 theta, therefore this first angle must be equal to 90 degrees minus 2 theta. Why? Because 90 degrees minus 2 theta plus 2 theta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. This is the sum of the angles in any triangle. Therefore, this first angle must be equal to 90 degrees minus 2 theta. Likewise, in the white triangle PBC, this angle equals to theta. This angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus theta. According to the sum rule, that said that the sum of the angles in any triangle is equal to 180 degrees. So in the next step, we did the construction. That is to say, from point P, we draw perpendicular on AC. Again, from point P, we draw perpendicular on AC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and AC. This point is point Q. By doing this construction, we get the green triangle PQC. In the green triangle PQC, this angle equals to theta, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus theta according to the sum rule that said that the sum of the angles in a triangle is equal to 180 degrees. In the next step, we prove that those two triangles can go into each other according to angle side angle rule. That is to say, the green upper triangle PQC, upper right triangle PQC is similar, can go to this white lower triangle PBC according to angle side angle rule. So why those two triangles are similar to each other? Why those two triangles can go into each other? First of all, those two angles are both equal to 90 degrees minus theta, and therefore they are equal to each other. In addition, this is side PC, this is the common side that belongs to both triangles, so we can write down that PC equals to itself, this is the common side that belongs to both triangles. And finally, those two angles are both equal to theta, and therefore they are equal to each other. So in total, we have found out that those two triangles can go into each other according to angle side angle rule. That is to say, we prove that those two angles and the side that is included between those two angles in the green right triangle PQC are corresponding equal to those two angles, and the side that is included between those two angles in the white triangle PBC. And therefore, those two triangles congruent to each other according to angle, side, angle, rule. Again, we have those two angles and the side that is included between those two angles in the rectangle corresponding equal to those two angles and the side that is included between those two angles in this right triangle. Therefore, those two triangles congruent to each other according to angle, side, angle, rule. And to know that the again upper triangle again PQC congruent, this is the side of congruent to the right lower right triangle PBC according to angle, side, angle, rule. And from the fact that those two triangles congruent to each other, we will derive that the corresponding angles, the corresponding sides must also equal to each other and the next. That is to say, PQ equals to PB. Why PQ is the corresponding side of PB? Because of the fact that PQ is located in front of angle theta, likewise PB also located in front of angle theta. So PQ is the corresponding side of PB. And so that we should find out that PQ equals to PB. But PB is 4, so can I do that PB is 4? From this equation, PQ equals to PB equals to 4. We know that PQ must also equal to 4 units in its length. This inside PQ must also equal to 4 units in its length. It's very easy to see from the drawing that the big right triangle ABC is similar to this small green triangle APQ. Why the big right triangle ABC is similar to this green triangle APQ? Because of the fact that this is angle A, that is the common angle that belongs to both triangles. So we find out that angle A equals to itself is a common angle that belongs to both triangles. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to theta and therefore they are equal to each other. Why this the angle APQ, why it is equal to theta? It is equal to 2 theta according to rule 3. Rule 3 says that the sum of the angles from one side of the theta is equal to 180 degrees. So which angles we have at the right side of the left side of the straight line AB at point P? We have the missing angle that we define as y plus 90 degrees minus theta plus 90 degrees minus theta must be equal to 180 degrees according to rule 3. Because again, according to rule 3, in the right side of the line AB at point P, the sum of the angles must be equal to 180 degrees. That is to say, 90 degrees minus the missing angle y plus 90 degrees minus theta plus 90 degrees minus theta must be equal to 180 degrees. Again, the missing angle y plus 90 degrees minus theta plus 90 degrees minus theta must be equal to 180 degrees according to rule 3. So here we have y 90 degrees plus 90 degrees 180 degrees minus theta is minus 2 theta. So in total, in this side of the equation we have y plus 180 degrees minus 2 theta. Well, on the other side of the equation we have 180 degrees. So we have subtracted 180 degrees from this equation. So in 180 degrees we get cancelled, and here also 180 degrees we get cancelled. So in this side of the equation we left with nothing, that is to say 0. But on the other side of the equation we left with y minus 2 theta. So in total we should find out that y minus 2 theta equals to 0. Here we added 2 theta to this equation, and we found out that y equals to 2 theta degrees in size. This is to say the missing angle y, the angle PQ equals to 2 theta degrees in size. Repeat quickly. In total we should find out that the big triangle ABC is similar to this small green triangle APQ according to angle similar to 1. Why? Because this is angle A, this is the common angle that belongs to both triangles, so I can write down that angle A equals to itself is a common angle that belongs to both triangles. Likewise, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 2 theta and therefore they are equal to each other. So in total, we found out that all the three angles of this big right triangle ABC correspond equal to all the three angles of this small triangle APQ. And therefore, those two triangles can go similar to each other according to angle similar to 1. And from the fact that those two triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AP of the green small triangle or side AC of the big triangle ABC equals to side PQ of the small green triangle or side BC of the big right triangle BC. AP is 5 over AC. We define AC as A and BC as B. So AC is A according to our definition. AP is 5 and AC is 8 according to our definition, and is equals to PQ. PQ is 4 over BC. BC is B according to our definition. Okay, again, PQ is 4, BC is B according to our definition. So in total, if we found out that 5 over A equals to 4 over B. If we cross multiply this equation, we found out that 5B equals to 4A. What is the meaning of this equation 5B equals to 4A? It means that if A equals to 5x, then B must be equal to 4x. Why B must be equal to 4x? Because if we substitute A by 5x, we get that 5B equals to 4A, and A is 5x. So total we get that 5B equals to 4 times 5 times x. We have 5 on both sides of the equation, so 5 will get cancelled. So after cancel 5 in this side of the equation, we have to leave B, while on the other side of the equation, we have to leave 4x. So in total, if we found out that B equals to 4x. In total, if we found out that if A equals to 5x, then B must be equal to 4x. And again, if we found out in total, if A C is equals to A equals to 5x, then B C is equals to B must be equal to 4x. Our task is to find out this green shape. So in the next step, we apply the Pythagoras theorem on this big rectangle ABC. According to the Pythagoras theorem, in any rectangle, the slope of the hypotenuse equals to the sum of the slope of the perpendiculars. So in this rectangle ABC, it means that AC squared, that is the slope of the hypotenuse, must be equal to AB squared plus BC squared. So again, according to the Pythagoras theorem, in the big rectangle ABC, AC squared, that is the slope of the hypotenuse, equals to AB squared plus BC squared. AC is 5x, therefore AC squared is 5x squared, that is 25x squared, and this equals to AB squared. AB is 5 plus 4, that is 9, therefore AB squared is 9 squared, that is 81, plus BC squared. BC is 4x, therefore BC squared is 4x squared. 4x squared is 16x squared. So we found out that 25x squared equals to 81 plus 16x squared. You have subtracted 16x from this equation, and found out that 25x squared minus 16x squared is 9x squared equals to 16x squared minus 16x squared is also, here we have to only with 81. So in total, we found out the 9x squared equals to 81. Here we divide this equation by 9, if we found out 9x squared over 9 is x squared, equals to 81 over 9 is 9. So x squared equals to 9. Here we took hold of this equation, if we found out that x equals to the square root of 9, that is 3. So x equals to 3, everything is 9. AC equals to A and A equals to 5x. 5x is 5 times 3, that is 15, so AC equals to 15. Likewise, BC equals to B, and B equals to 4x. 4x is 4 times 3, that is 12. So in total, BC equals to 12, and AC equals to 15. Our task is to find out the layer of this green shape. What is the layer of the green shape? The green shape is actually the green triangle APC. So our task is to find out the layer of the green triangle APC. What is the area of the green triangle ABC? Actually, you know that the area of the triangle equals to the base of the triangle times the height of the base over 2. We choose the base of this green triangle ABC as AC, and therefore the height of the base is PQ. Why? Because PQ is 90 degrees with the base AC. So the base is AC, the height is PQ over 2. Again, the base BC, the base of triangle APC is AC according to our choice. Therefore, the height must be PQ over 2. AC is 15, PQ is 4 over 2. Okay. AC is 15, PQ is 4 over 2. 15 times 4 is 16, 60 over 2 is 30. So according to the first method, we actually found out that the area of this green shape is equal to 30 square meters in size. In the next step, I put on the solution according to the second method. What is the area of this green shape according to the second method? This one triangle PBC is very easy to say that triangle theta equals to PB over BC. The white triangle PBC, triangle theta equals to PB over BC. We define BC as B. Therefore, in total, triangle theta equals to PB, this is 4, or BC, this is B. Again, PB equals to 4 according to what is given as the equation, BC equals to B according to our definition. So in total, according to equation 1, we have found out that triangle theta equals to 4 over B. The next step, focus on this big triangle ABC. On this big triangle ABC, it is very easy to see that tangent 2 theta equals to AB over BC. So in the big triangle ABC, tangent 2 theta equals to AB over BC. AB in total equals to 5 plus 4, that is 9, over BC, that is B. So in total, tangent 2 theta equals to 9 over B. According to equation 2, we have tangent 2 theta equals to AB, that is 9, over BC, that is B. So in total, according to equation 2, tangent 2 theta equals to 9 over B. So tangent 2 theta according to equation 2 equals to 9 over B. According to equation 1, we only found out that tangent theta equals to 4 over B. The next step, we implemented the trigonometric identity that said that tangent 2 theta equals to 2 times tangent theta over 1 minus tangent square theta. So we implemented this trigonometric identity in our question. Tangent 2 theta equals to 9 over B, so we substitute tangent 2 theta in this trigonometric identity by 9 over B, and it equals to 2 times tangent theta. So tangent 2 theta in this trigonometric identity by 4 over B. So it is 2 times tangent theta is 4 over B over 1 minus tangent square theta. So it is 1 minus tangent square theta. If tangent theta equals to 4 over B, it means that tangent square theta must be equal to 4 over B squared. 4 over B squared equals to 16 over B squared. So total tangent square theta equals to 16 over B squared. So total according to equation 3, we found out that 9 over B equals to 2 times 4 over B over 1 over 16 over B squared. 2 times 4 is 8, so here we have 8 over B equals to 1 minus 16 over B squared equals to 9 over B. And again, so that we should all know that 9 over B equals to 8 over B over 1 minus 16 over B squared. So here we multiply this equation by 1 minus 16 over B squared. So in this side of the equation we have 1 minus 16 over B squared over 1 minus 16 over B squared, that is 1. So this expression we get cancelled, so in this side of the equation we left only 8 over B, but here we multiplied now 9 over B by 1 minus 16 over B squared. So in total, according to equation 3, we found out that 9 over B times 1 minus 16 over B squared equals to 8 over B. This is 8 over B. So here we have B on both sides of this equation, so B we get cancelled. After cancelling B, in this side of the equation, we left only 9 times 1 minus 16 over B squared, while on the other side of the equation, we left 8, because B will get cancelled. So in total, according to equation 5, we found out that 9 times 1 minus 16 over B squared equals to 8. Here we open the brackets on this side of this equation 3. 9 times 1 is 9, and 9 times 116 is 144, so in total this expression equals to 144 over B squared. So in total we found out that 9 minus 144 over B squared equals to 8. Here we subtracted 8 from this equation. We found out of here that 9 minus 8 is 1 equals, so in this side of the equation we have in total 1 minus 144 over B squared equals to 8 minus 8 is 0. So in total we found out that 1 minus 144 over B squared equals to 0. So here we added 144 over B squared into this equation 3. So 144 over B squared plus 144 over B squared minus 144 over B squared is 0. So here we have to only with 1. Right, 0 plus 144 over B squared equals to 144 over B squared. So in total we should find out that 1 equals to 144 over B squared. Here we multiply this equation by B squared. And we found out that 1 times B squared is B squared equals to 144. So in total, according to equation 3, we found out that B squared equals to 144. Here to go out of the equation, if we found out that B equals to the square root of 144, this is 12. So B equals to 12 and since left. BC equals to B and B equals to 12. So BC equals to 12. Our task is to find out the area of this green shape. The green shape, the green triangle ABC. So our task is to find out the area of the green triangle ABC. What is the area of the green triangle ABC? Actually, we know that the area of the green triangle equals to the base of the triangle times the height of the base over 2. We choose the base of this green triangle ABC as AP. Therefore, the height of the base must get matrix with the extended base AP. The extended base AP is AB. CB is definitely greater than the rest with AP, because it is a right angle. In total, the base is AP, the height is CB over 2. So we choose the base as AP, therefore the height of the base must be CB over 2. AP equals to 5, BC equals to 12 over 2. AP equals to 5, BC equals to 12 over 2. 5 times 12 is 16, 16 over 2 is 30. So in both methods, we have found out that the artistic shape, that is the area that we're looking for this equation, is equal to 30 coordinates in size. Okay, thank you very much.